Hello, everyone. Thank you for tuning in to this episode of our podcast here at Software Plaza. We recently actually rebranded from Amazic to Software Plaza. So, in case you're used to following us on our different social media and on our website, Amazic, want to update you that with this rebranding, now you'll find us at softwareplaza.com, and we're in the process of just updating all of our social media handles right now. So just know that we're going through this transition. But what's not changing is our focus on topics related to the cloud and DevOps, cloud native. And today we're going to be talking about security, and more specifically, software supply chain security. I have with me today uh, two guests who are working in the trenches in this space and are here to talk about all that they're building and the cool stuff that they're seeing around them. I'm quite excited for the conversation today with Scott Robertson, who's the CTO at ActiveState, and Pete Garcin, who's the Senior Director of Product at ActiveState. Scott and Pete, great to have you guys with us. Thanks for joining. How are you doing?
Oh, amazing. Thanks, Twain. We're really excited to talk about a topic near and dear to our hearts.
All right, yeah, software supply chain security. Before we get into all of that, tell us a bit about yourselves, your journey so far, and how you got to active state.
Pete, you want to start?
Yes, so I've been working in technology pretty much my whole career. I did about 15 years in video games before I switched over to working in open source. Open source is something that's been sort of near and dear to my heart my whole career, and so um, I was happy to get a chance to work with ActiveState, and so I've been at ActiveState now for about 7, almost 8 years. And Seeing the evolution of active state from providing sort of Perl and Python distributions all the way through to the um, sort of self-serve platform for managing all of your open source and helping you manage your supply chain security at active state. So that's been a really interesting evolution to see that change from when I started to where we are today. I'll hand over to
Neat.
Scott.
And have you always been involved in product, or have you moved around
Yeah,
roles?
pretty much. Yeah, like I did the latter half of my career when I was in games, so I was a producer kind of thing, which is basically the same role as a product manager. So, and I did start at ActiveState doing developer relations kind of thing, to being a developer advocate. So, always had a, keen ear to the developer perspective, um, in open source.
All right, neat. Scott.
Yeah, I mean, my background, I've always been kind of the startup guy with a focus on enterprise software. I like to tell everybody that this is actually my second tour of duty at ActiveState. I was with them in the early 2000s before I went off to work at a bunch of other kind of
Wow.
startups and things like that. Um, the kind of interesting story when people ask, well, why did I come back to ActiveState, was I was working at a startup called Six Sense. We were working on predictive analytics, and I was in charge of the data science, the data engineering team. We were helping data scientists take their models and get them in production. And it was kind of a funny day. I was literally sitting at a laptop with a new data scientist that we had just hired, and they had been working on a project for about a week or two, and we were trying to get this thing into production. And it was always kind of the same story where like data scientists would just run out and just copy and paste code from all over the place to get their system up and running, and then it would be like investigating this crime scene to figure out what they did to get to this point so that we could turn it into something that we could run at scale. And my old boss called me up and said, "Hey, how would you like to come back to ActiveState?" And I was like, I did some work with them, and their kind of claim to fame is they help port languages like Perl and Python in the late 90s to the enterprise operating systems that people want to use. So we were helping port Perl to make it work on like Windows and big iron machines and things like that. And I was telling my former boss Bart, who was the CTO or CEO at the time of ActiveState, is like that. ActiveState's business is one of the most boring businesses in the world because it's all dealt with managing open source, and I really hate it. In fact, I'm dealing with that problem right now where people had gone out, got all these dependencies, and they're just in dependency hell. Nobody wants to do that. He's like, you're right. Nobody should be dealing with dependency management issues. Why don't you come back to ActiveState and figure out a better solution for that? And that kind of became the seeds to the idea that Pete and I started working on, which is like open source is this great tool. Enterprises have adopted it, they're relying on it, but at scale, when you start working with teams and managing and tracking it, it becomes, in some cases, an impediment to the way that you work your code. And it's like in some estimates, we have like 30% of your time is just managing your dependencies or the consequences of the dependencies you have. And it just kind of became our driving mission. Like, how do we get rid of all of that minutia and work that everybody has to deal with managing open source, whether it's acquiring it, building it, or now lately just dealing with all the security consequences of it. And it's like more and more of these things that we rely on are just taking more and more of our time and taking us away from the greater joy of it. And that kind of became the roundabout way and the motivation of rejoining ActiveState and became our new mission. It's like, let's just get rid of all of the pain points of using open source so we can all get back to what we love, which is developing software and making great products for people.
All right, quite a story. So I have to ask, how old is ActiveState then?
Oh, I think we were founded in, I should know this, 97, 98. So we've been around for about 20 years. Maybe I'll just give you the brief history of ActiveState. I kind of touched on that. We, like I said, our claim to fame is we helped get, it started off with Perl actually. So at the time the web was taking off, people were learning how to build CGI programs on web, and the tool of choice at that point was Perl. And people wanted to take Perl to work, but it wasn't supported on the hardware and operating system platforms that everybody needed. And so ActiveState helped Microsoft port Perl to Microsoft Windows, and then we just built this great business of um, supporting getting open source in the enterprise. And I sometimes joke that we helped create the problem that we're now trying to solve, is everybody wanted to use open source inside of the enterprises. And so we started dealing with a lot of the complicated problems of getting open source to compile and build and manage dependencies. And a lot of this was at the time when dependency package managers and things like that weren't a thing that the community was providing. It was like, if you wanted open source, you had to go to Usenet groups and collect it yourself. And so then what you saw is you had company players like yeah, Red Hat and SUSE and stuff like that collecting open source and making Linux distributions. And what ActiveState did was we collected open source components for developer use cases along um, language lines. So if you wanted Perl, we'd get Perl to work across multiple different operating systems at the same time, or if you wanted Python, we do the same case. So we've been at the whole open source management game for quite some time. A lot of it has been helping companies deal with like license management issues and build related issues, and now it's morphed into security risks. And so there's just a lot of all these great advantages you get, and there's also a lot of risks that are involved with it. And ActiveState's here to help
Mm,
enterprises deal with those
yeah,
problems.
wow, that's quite some pedigree there. But yeah, really long that you guys have been at the problems and challenges with open source security. So yeah, really curious in all that you guys have been working on and just your opinions on the way things are today. Yeah, and I wanted to talk a bit more about just how things have changed since then, uh, since when Active State started, and more recently now we're talking about security in terms of cloud native, and Kubernetes is now like the biggest, most widely used open source tool in the cloud, and it's pretty much like defining, it's bringing people together around, uh, just how to run things in the cloud. And so it's become a big part of security conversations. I want to get your take on just what has changed, maybe in your stint too at Active State when you said you came back and you guys were building something new. What was the scene? What did you notice that's changed, that's new, and what have you guys been building?
Yeah, I mean, my biggest perspective, like when I left ActiveState, um, at that time, I was kind of alluding to this, the acquiring open source was the biggest challenge, and dealing with the licensing issues related to it. At that time, organizations were very fearful of what bringing in something like a copyleft license might do to their code base. And then kind of like the bigger shifts that happen in the marketplace, and I often like to tell people in the battle between closed source and open source won. We're all comfortable with it now. We all bring it in easily. In fact, we might have become too comfortable with it. And then on the other case of it, we have all these communities that have produced easier ways of distributing and acquiring open source to the fact now that we got in the state of the world where it became just really easy to, I'm working on a problem. Oh, look, there's a library. I can include it into this. Seems like a bunch of people are using it. I'm going to include it. And then when you hit that at like enterprise scale, I mean, we deal with organizations that have development teams of 10 to 30,000 people and all the way down to 50. But when you get into these large, lots and lots of teams, lots of competing projects and deadlines, people have just been grabbing all these components off the internet without understanding the provenance of it, lobbing it into production and wondering how things are happening. And now the nice thing is that containers and Kubernetes have come along to make that a little bit easier to contain and release that. But in our line of work, what we've just discovered is open source has just come into these organizations at this big accelerated rate. And the biggest challenge we see right now is people don't even understand how much open source is in their organization, where it came from, who built it, who put it there, when was the last time it was used. And you compound that to the fact that you've got these threat actors now, like we deal with companies that build software for nation states, and those themselves have become targets for attacks. Right? People are saying, "Hey, there's all this stuff being built and produced by uh, communities, and they're not, they're looking to build great software. They're not really thinking about things from a security perspective." Well, that just puts a big bullseye on if I want to get into an enterprise, if I understand what open source you're using, now I have a blueprint of how I might be able to get into your systems and find out more information about you and make you more vulnerable and attack. So it's like we've made it really easy to consume open source, and now we're kind of suffering the consequences of that. And I think it's for good reasons, but that's to me the biggest change. And now it's not what I see ultimately is our use of open source is also starting to slow us down because we have to start worrying about all these other consequences. And people share take on this.
Yeah, I think that the scale at which enterprises are able to ingest and like utilize open source is probably the biggest change, right? At the beginning when ActiveState was founded, open source was still pretty niche, you know what I mean? And what, wouldn't have been as widely adopted. And the rise of things like GitHub, where it just became so much easier to access the open source and get it used in your product to the point now where like over 90% of the code in pretty much any code base is going to be consisting of open source. And the
It's quite a
dependency chain is going to be huge, right? If you modern stacks, even for things like websites, have hundreds and hundreds of dependencies. And most people don't even really know what, all of the things, not just in terms of like uh what's being used across your organization, but just even an individual developer, for the most part, when they pip install something, they just think, oh yeah, I'm installing, TensorFlow. I'm installing, whatever, Flask or Django or something. And but they don't realize that, okay, but you're also installing all of this other stuff, right, that goes along with it. And those stacks are getting more and more complex. And there's just the scale of it is just so large now that uh, you really need specialized tools to be able to keep track of it in a coherent way.
Maybe I'll
Mhm.
talk a little bit about the scale because I think developers, we like to we do a lot of complexity. So in our mind, we always try to trivialize things to just these things, but we don't sometimes take a breath back and look at what we've done. It's like if you think of like modern application development, okay, you're on a team of a 100 people and you're releasing software, and maybe your software, uh, we still have customers that ship software to people in on-prem locations, and then they're running things in the cloud or running in containers. And now it's like every version of that software that you're releasing might have a different set of dependencies that you have to worry about over time. But it gets even worse than that. Like when you're in the development process, even the difference between what I'm doing at my laptop versus what Pete's currently doing at that laptop could be changed. Like pip will give you, or npm, or these packages managers, unless you're like really meticulous about how you're managing your dependencies, is going to just give you the latest version of whatever's available right now on the internet when you make that request. And um, if you're not diligent about all of those processes, or you don't have tooling in place that makes that consistent, which is kind of if you want to get to what ActiveState is fanatical about, it's repeatability and consistency. But we're trying to build these tools so that you have the exact same experience on every single environment that you're building your code in. But if you're not diligent about that, all of a sudden what happens is you start just bringing in random different combinations of open source components that look like they may work, or may look like they work on your development machine, but might be different somewhere else. Or who knows, it's really easy to slip a vulnerability into that particular case. I don't want to get too much into the FUD side of things, because I don't really think that's what ActiveState's about, of saying, hey, open source is scary to use. It's just the scale of having to deal with it makes having to worry about these issues a lot more complicated, and we're more focused on how do we contain that chaos for you so that you don't have to think about these things.
Mm-hmm. Yeah, yeah. You guys have really described the various challenges around open source security really well from various perspectives. I see on your website, one of the first things it says is what ActiveState does is discover, prioritize, and curate trusted components. And I want to dig into talk a bit about that and the approach you take, and does is something like an SBOM, which has definitely been in the news a lot, and it's been getting a lot of attention from security folk. Is that a central piece to how you do this, or is that one part, but you got an overarching security strategy that you follow? Could you talk a bit more about just how you approach all of these challenges?
Yeah, I'm glad you're talking about SBOMs. It definitely is a central thesis of this. And in fact, what ActiveState takes is what we like to call an SBOM-first approach. So what you see currently out there in the field, which is different, is a lot of people build and assemble their applications. They build the application in their CI/CD systems, and at the very end of the process, they generate an SBOM. Here's the bill of materials that we use, and we kind of think of
And
that
and
stance
just
as,
and just for the record, could we just like explain what an SBOM is really quick?
oh yeah,
If you
absolutely,
did.
yeah, thank you. Yeah, no, SBOM stands for software bill of materials, and it's essentially, if you go back to the problem we're talking about, which is just like open source is pouring into an organization to the point now where people don't even know what it is an SBOM is a record of saying this application or library that is being used is comprised of all these other individual open source dependencies. So you'll call them, some people will call them indirect dependencies or transitive dependencies. It's basically, this thing depends on this, that depends on this, that depends on this. The bill of materials lays out all of those individual components, their version. If you're lucky, it has checksum information. It can basically give you a way to say, this is exactly what should be powering my other application. And the purpose of that bill of materials is to tell you that later on, you know, a vulnerability might be detected in your open source somewhere in your open source dependency chain, that, hey, I'm actually impacted by this, and therefore I should update that software component. And that's kind of the thing that people struggle with, is they don't understand all of the dependencies that are consuming the power of their application, or the impact of changing that component on that. So SBOM is kind of a record. There's a couple of different formats that people have created to kind of give you that inventory of what you're consuming, so that you have some more data to understand the impact of vulnerability threats or upgrades, or or everything else like that. And
Mhm.
um, so they're kind of being championed as this thing that's going to help us with all of our security problems. And it's, they're right in some cases, but there's also how you go about producing your SBOMs and what you go about doing to manage them is the point
Mhm.
that I don't see enough people talking about in this, because that's the real point. It's just having a list of what's in your components is just the start of the
Mhm.
process. And so this gets into like kind of unique take that we have is we, like I was mentioning, is we focus on what I call the SBOM-first approach. So instead of letting it get all the way through your CID process and then you build your bill of materials, we start by assembling the bill of materials first and then building your
Mhm.
application off of the things that we've created in the bill of materials. And so the what probably makes us the most unique out of everybody here is that we've been at this whole software dependency management longer than even the open source communities have. So we have our own systems and tools and processes that we've used to manage the build complexity. There was a point actually when I rejoined ActiveState, we were doing over 1,000 different unique builds for uh, various organizations and in just Python alone. And it was like some 30 odd combinations of operating systems and hardware platforms. So we got really good at just understanding and managing what open source had. And that became the platform that you see today. And what we're doing is we're taking a catalog of all the open source that's being released on a nightly basis in the open source, and then we're capturing that in an immutable catalog. So we have exactly those individual components that are always reproducible. We can always give you the exact same bit of source code. Everything we then deliver to our customers um, is built from source from that code that we've captured into the binaries that we distribute it back. And we can deliver that as we deliver the bill of materials from you. And at the heart of all of this is a component that we call our solver, which is sort of, we have created a system that is, I like to call it it's kind of the superset of all software dependency managers out there. So we understand how Python manages its software dependencies or how Go manages its software dependencies. We're working on Rust right now from these things. We're putting them all together so that you can just come to our platform and say, I need this open source component. We can figure out the transitive dependencies for that component. And even more uniquely is we will jump across ecosystems, which is one of the other big challenges that you'll see in the ecosystems today is like Python only knows about Python dependencies. And then if you're on Rust, you're on your own. You got to learn another set of tooling for that. Or if Python is using a Java component, um, you'll have to understand the Java stack, various things like that. What ActiveState's done is we've modeled out the software dependencies across ecosystems all the way down to the bare metal libraries from that. And that is how we can just, you tell us one dependency, we can figure out the complete set of transitive dependencies. We build the SBOM, we generate the SBOM from that. We build your open source components, and then we can give you that manifest saying this is exactly what you're using. And then that's just the start of the story, right? So now that we have this SBOM, we're cracking that SBOM. So now as we're monitoring the internet for the rest of the open source components out there, we're able to say, oh, look, there's a vulnerability. We know all of our customers who we've generated a build off of those SBOMs for right off the bat, and we can notify them. But not only do we notify them, hey, you got a component that's missing, we can notify them like, hey, your component has a vulnerability. We already know the dependencies that you have, so we've rebuilt the entire set of dependencies for you, and it's ready to go. Or in some cases, we'll be like, we've done it, but guess what? You're in dependency hell. If you try to take this update, yeah, you can't take the fix. And that's kind of the unique part of ActiveState is because with this SBOM first approach, we just have much greater clarity of the open source you're using and its impacts on the updates and changes from that.
All right, really interesting. Pete, did you want to add something to that, or do you think it's a good time to kind of get into a demo or a walkthrough of
Maybe
how?
that's yeah, maybe it's a good time to sort of fire up a demo here and walk you through what this actually looks like in terms of that SBOM first approach and what it
Mhm.
looks like in terms of being able to being able to get that sort of reproducible history for anything inside your organization when you're making a project. So let me just share
Mhm.
my screen here, and I will uh, screen, and I'll walk you through. So the
All
first
right.
thing,
Yeah.
can you see if you can see everything? So the first
Yep.
thing you're doing, right, is we're saying is we're starting from an SBOM, right, to say like both in terms of how our system works, but also in terms of discovering. You might have a lot of SBOMs inside your organization. Thing we talked about earlier was like, oh, what actually is being used inside my organization? I have a whole bunch of teams. They're all using different components. Um, they might have SBOMs for those things. Maybe I want to be able to scan my Kubernetes cluster directly and see what's actually running in production. Maybe I want to look at my GitHub repos, right? And I might have, whether it's package.jsons or pip files or, you know, requirements.txts inside my repos. That's another way I can discover what I'm using. But the SBOM might be the most sort of comprehensive. And so whether you're generating it from our platform and going directly from our catalog, or whether you are using, a third-party tool where you can generate an SBOM, you can essentially take those SBOMs in the different formats, whether it's SPDX, CycloneDX, and you can import them into our platform. And what our system will do is analyze those and break them into different applications that you're running. So in this case, I've got my local environments, and this one I've got my production environments. And then it's going to do is going to do an analysis of those projects and create a kind of dashboard for me to say, hey, here's the breakdown of the stuff that the software you're using inside your organization. You've got 2,000 something dependencies. 69% of those are C. Some of them are Go, Java, Python. And this is your vulnerability profile, right? I've got this vulnerability profile where, I've got 12 criticals here and 77 highs, and all my individual applications are broken down here into specific little projects. And I can
Hmm.
go into that project and I can see the components, right? I can see this is a Debian base image, and here's the Python packages that are being used. Here's its vulnerability profile, and here's all of the dependencies that the system has solved for inside my organization, inside my project. And so if I want to do remediations with that, though, what I can do is have the system check for some available remediations because, like Scott said, we have this whole catalog, right? We know everything that's being used. And so we can say, actually, in your little Python ML runtime here, you currently got 73 total vulnerabilities, but we know from our catalog and the versions that you're using, that if you go from, in this case, NumPy 122 to 126.4 and Pandas 1.2 to 2.14, etc., we can eliminate all of those critical vulnerabilities and dramatically reduce the highs. And so you can see this, it's going to show you the kind of diff of this is the changes we're going to make to this project. And it can also indicate that there might be some breaking changes that you might have to uh, take a look at here because
Hmm.
our system is focused really on your third party code, all your open source. We're not ingesting your first party code. And so if we look at over here at it's going to say breaking changes, you're going from NumPy 122 to 2.13. That's a major version change. There might be some sort of changes to the function signatures, that kind of thing, parameters that might impact your code. We can't tell you definitively, but we can at least give you the information that you need to sort of vet whether you want to take that change or not. And so if I'm say, oh, I'm happy with this, then what it will do is we'll update the project, make those changes. And so then when I go over here, it will then build this stuff. So it'll build all those components from source. So giving you that kind of provenance of, I know definitively that I'm getting this from ActiveState, right? If I'm just like pulling something from NPM or, PyPI or something, I'm pulling a binary usually from the public repository, but I don't necessarily know where that was built. Like, was it built on somebody's laptop in a secure CI farm? Where was it built? Whereas what we're doing is rebuilding everything from source here, and so definitively that, hey, this is built from source on our platform. And what it can do is then give you the instructions to do any integration. So in this case, if I'm using Docker, it'll say, oh, you need to update your Docker Compose YAML file. No problem. We've made a little pull request for you to show you how to integrate that into your deployment. If you're using Helm, et cetera, et cetera. It's making those changes for you. And we even give you the ability to drill down and view the logs. So if you want to see, here's the actual compiler output from this build, I can drill down and to see in every component as it was built from source. And then ultimately what you can do is, because we are, like Scott was saying, we're mirroring all of the open source. One of the things we've done is kind of married the concept of source control and dependency management. So you can see like a vetted history of everything, that every change that you've made. And so if you go back on, and actually I have one open here. If I go back, I can see that I've made a commit here on my history tab, right? This was made on this particular date by me. And here's the catalog revision ID. I can see all the exact changes that I've made. I added these languages and so forth. But I can also see this catalog revision ID that this is the state of the world at that time, which really I kind of think differentiates us. So we have that catalog. If I run npm install on Friday, then run it again on Monday, I might get a different result, right? But in our case, because we have a catalog revision ID, you can go back in history and definitively get exactly what you were looking at a particular day and time. And so that's the sort of like high level loop, right? Is that what I'm doing is I'm discovering open source that's running in my organization. Then I'm getting tools where I can, so if I go back here, getting information and data that I can use to prioritize the changes, right? I can curate the changes that I'm doing as well, both through the catalog and selecting specific versions. We also have the ability to set policies and stuff like that. So you can be like, oh, I don't want any copyleft licenses, or I don't want any vulnerabilities below a certain threshold, this kind of thing. Um, and so you do the curation and then you do the deployment, right? And so that was the last piece that we saw here, where in our vulnerability, you could do the deployment, whether it's back to your Docker thing or your Kubernetes cluster, or maybe it's just like your development laptop. I'm just going to pull this down on my development laptop for the next iteration of what I'm doing on the feature development.
Mhm, mhm. Wow, great. Oh, this is a wonderful demo. And I quite like how just really helpful at different points your platform is in just suggestions and even thinking of things that might break. That's quite impressive, being able to see what might break and even being able to just update the projects with the click of a button. Really just amazingly helpful is what comes to my mind when I look at just the demo. So really great demo there. Scott, is there anything more that you wanted to add to what Pete was saying?
No, I mean, but maybe I'll highlight why this is so helpful is really the focus here, and where we think a lot of people get this wrong. A lot of our competitors and get this wrong is we actually try to model the software after the way that dev teams and dev operations think. And we think about them in terms of the components themselves and dependencies, right? When you're talking to somebody who's like, oh, I'm using TensorFlow and Flask and I'm putting these things together like that. But a lot of the tooling that you see out there are all trying to use um, the native tools and are trying to make that your problem. Yeah, like, hey, we see that you have dependency, but we're not going to even tell you how to fix it. You have to be the expert in running Maven if you're a Java person, or Pip if you're that, or Cargo if you're Rust. We're trying to give you the natural components that you're actually more useful for. Your vulnerabilities are in a specific open source component. When you're adding a dependency, it's another open source component. And that's kind of like the relentless focus that we're trying to do, is just get you away from the actual tools that you have to use and get you back to the actual more problems and tasks that they have at hand. And that's what then generates a UI that looks like that. And it's just kind of really just built into the mental model that we have here and what we're trying to bring to the world, so that we can really accomplish the mission that we're after here, which is we really want to accelerate your development and make you have to stop thinking about all of the extra, minutia that goes along with managing open source projects.
Yeah, for sure.
Yeah.
That's, I think, a really key point is that a lot of them basically give you recommendations that, oh, you've got a vulnerability in your project here. You've got a vulnerability in Pillow. You need to update it. And maybe you would need to update it to 10. But what is actually going to be involved in updating that to 10? Am I going to have to build a bunch of stuff from source? Am I going, do I even have the tool chains installed on my laptop to do that? You know, What happens? Oh, I update this to 10 and then something else breaks and you get in that sort of dependency hell loop. Whereas our platform is doing all that heavy lifting for you, including building it from source so you know, first of all, you don't have to have the hassle of building from source and then you know where it's coming from so that we've already done the hard work of, okay, yeah, you should go from version 9 to version 10, but no problem. We're going to do all of that work for you, not just, sort of generate you a task list that you have to do and deal with the fallout kind of thing.
Yeah, yeah, totally makes sense. Yeah, I mean, every team has a budget in terms of time and how much they can actually work on, what problems they can work on and what they can't. And so I think it just, this really gives them a clear picture of, what are the different options they have, what's high priority, what can they, maybe leave for a later point in time. Yeah, in terms of the numbers, I like that it really gives you a number here, how many vulnerabilities you have, how many are critical, how many are high, and all of that. And what do you see with your clients that work with ActiveState? Do they actually reach zero, and do they maintain zero vulnerabilities, or is that more like a nice to have and not really necessary, but so long as you go to, a state that you're happy with, that's good enough?
That's a really good question. Yeah, the zero vulnerabilities is an aspirational uh, topic. There's never going to be such a thing as zero vulnerabilities. It's, because even code today that you think is vulnerability free today is that's just our best guess at the moment. There are threat actors out there right now constantly probing code and trying to find new ways to exploit it. And in some of these cases, these things that make you vulnerable are also the things that are necessary to make the operations complete. So there
Mm,
is a balancing act that is always going to be there. So there's never going to be this 100% free, just like, security in your home is never going to guarantee that you're 100%. You can have a secure home, but you can never leave your house and nobody, nothing can get in and nothing can get out, right? That's just not a practical perspective. So our take on security is more about understanding what is there, understanding the risks, and being able to decide if that's there. So being able to decide if that's something you're going to accept or not and make changes to it. So it's more about making it easy to understand your posture and the changes you are. And I think the greater focus, though, should be more on not so much eliminating all the vulnerabilities. Well, definitely eliminate critical and high vulnerabilities, but there's other ones that are kind of harder to exploit. But I think the other focus should be staying current with the open source communities, so that way you're current on top of it. And I would say that probably the biggest mentality problem that I see is there's the old adage in engineering, which is if it ain't broke, don't fix it approach, which is leads to I've written software 10 years ago that I haven't updated on. But the longer you put off keeping your updates, the harder the task becomes in the future. So a lot of more what we're kind of focused on is trying to keep you current, um, so that if something does major come through, that you're not, it doesn't turn into, like, we've seen some initiatives where it takes a company a year just to update their software dependencies because they put their updates off so long. And so that's really what we're more focused on, is how do we keep you more current? How do we take all the pain away from staying on top of it? Because little incremental updates is much easier to manage than something that you put off for 10 years. And so that's a lot of where our focus is understand the risks and then make it so that updates are less painful. And then can you stay on top of keeping your updates done? That's the best way to be, um, to keep your security posture. Having chasing an absolute, like a number of just zero vulnerabilities, though, is kind of actually a fool's errand in a lot of cases. Pete, you could probably explain that
Well,
better than I
yeah,
could there. Yeah.
and in some cases it's not actually really reflective of reality in the sense that um,
mhm,
not all the vulnerabilities that are reported might apply to you, right? In the sense that, you are not calling the function that is vulnerable. And so even though that library as a whole has that vulnerability, you're not exposed to it because you're not calling that function. Or
mhm,
the environment in which it's deployed has a low risk, risk profile for you. It's like, oh, well, this is just running on, Bob's laptop kind of thing as a test server, where it has no external access. we're willing to accept that risk kind of thing. And so therefore you don't necessarily want a nuisance annoying, a nuisance alert, right? So getting, always getting everybody to zero, on the dashboard kind of thing. You don't it's not always a case of, you have to remediate everything. Um, uh, and, sometimes they're disputed. And there's also, a wide variety of severities, right? Like you're going to have tons and tons and tons of low severity
Mm-hmm.
vulnerabilities up there that, you know, might not have any kind of material impact on you versus like obviously a critical one, those the critical ones you need to remediate, ASAP, and you often have to remediate those ones to maintain security accreditation, that kind of thing. So you have to agree to an SLA for those. And so that's like probably where more of the energy. So, the sort of absolute zero number kind of thing is more aspirational than reflective of a real reality where a lot of these things might not be applicable to you.
Mm-hmm. Mm-hmm.
Yeah,
Yeah.
probably worth highlighting is maybe the dangerous mindsets we have. Like I said, is one of them is if it ain't broke, don't fix it. Another problem that you end up having with, especially in the security space, is dealing with false positives. There's many more false positives saying, "Hey, you're vulnerable," when you're not. That eventually starts to desensitize your team from doing, staying on top of these things. And so it is a balancing game, that you're going to have to do. It's a chasing zero or being diluted by the false positives, like saying, "Oh, I'm not really vulnerable because these alarms are going off at the time." Those are all things that make us stop doing the good activities of keeping your software up to date and trying to eliminate as many vulnerabilities. It's like these are the things we have to do. Um,
Mm-hmm.
and then we're just looking for ways to. We at ActiveState are looking for ways to make that as least painful as possible for you, so that you can get back to what you really want to be doing, which is innovating and creating great technology.
Yeah, yeah, makes sense. As we wind down, I want to get some thoughts from you on just changes that are probably influencing this space of supply chain security, open source security. And one thing that is definitely on a lot of people's mind is AI and ML, what impact that's having. Just want to know your thoughts on, what you see happening. Is AI coming into the picture in security? How, and have you guys already started to integrate AI in any way in your product? Any thoughts on that?
Yeah, I kind of think about this in kind of two spaces. One, a lot of these models out there today are being trained using open source libraries, and some of the biggest, most active projects out there are data science libraries to help do these models. A classic example here is like PyTorch, and there's a lot of good examples of like friendly security researchers who are actually attacking supply chains and proving them out. And the thing that's interesting is they're picking these data science packages to kind of prove them out. So there was a great one. Oh, hold on a second. Let me look up this article where these researchers were just looking into how PyTorch was assembled by open source uh, communities. Let me get the name. This is a great paper. I think people should really. Oh, yeah, Playing with Fire. By John Stawinski. He wrote this researcher team. They went out and they analyzed how PyTorch was enabling their community of developers to help build PyTorch, and they analyzed how easy it was for them to get in. And I don't mean to be picking up because I think this just is an example of this project where this community has made it really easy for people to contribute code and build it into PyTorch. And then I start playing with that model. It's really easy to contribute code to PyTorch. What happens when people can contribute things that can also start impacting models? And then where does that danger pop up? And to me, what I really start thinking about a lot is where AI becomes a security threat is when you start hooking AI up to other tools that have ability to manipulate the outside world. And that's all going to be done through open source, right? So I'm going to take my AI model, it's going to make a decision, and then it's going to then talk to my open source components that can then have some impact. It can insert data into my records, or I know, God forbid, it's attached to some kind of utility system out there in the world, and the AI just all of a sudden does something bad and opens the floodgates on a dam or something like that, right? So these are like I'm trying to think like the worst case scenarios, and we'll start thinking about where we fit in the world, and where we see that happen, that spaces where AI starts interacting with these open source components we have, and we think that we need to understand that part. And this goes back to we just had a whole conversation about managing security, so audibility and visibility. You need to understand what LLMs you're using, and you need to understand how they're interfacing with your source code and your open source components. Um, and you need to be aware of those threats and vulnerabilities and security, and you need to be able to react to them and stay on top of them as fast as possible, because those threats could be coming. Maybe a model is compromised, or maybe the model just does something silly, right? But that silliness could then become some drastic impacts. And so the only way we're going to be able to stay on top of this thing is have visibility into these things, and stay on top of it. So it's kind of using that same philosophies that we built for managing open source. We're looking at those intersection points, and yeah, there's probably an AI story here. Maybe Pete, you can chat a little bit about that, the play to help manage that. We're starting to actively put those things in place, but at the core of it all is like you got to understand what you're using, who's using it, who put it there, why it's there in the first place, and then make sure you're monitoring the outside world for known problems so that you can stay on top of it. That's kind of where we see ourselves fitting in, and just making that easy to consume and understand those components. But hey, Pete, what's your thoughts
Yeah, I
on this
think
one?
I think that's a good way to think about it, is that those increasingly the LLMs are becoming, like, those models are becoming part of your stack, right? They're almost like another library that you're using. And so does that library have a vulnerability? Does that model have a vulnerability in it? Or what specific version are you using and where is it deployed? Maybe you have it deployed in 50 containers and you're using, some of them are running a slightly older version for whatever reason, and so being able to uh, monitor and observe those things is really, really important to being able to know whether you're, impacted. So you can take a remediation path, and you can say, oh, well, we need to update the version of that LLM, or maybe we need to pull it down and retrain it, or, there's all kinds of, this is totally emerging right now, right? Like that this is starting to change the sort of paradigm in terms of how people think about how stuff is deployed. And that's just from like almost like an inventory, like, management standpoint. It doesn't even get into what these things can do. Obviously, we've seen a lot of usage for them for code assistance kind of thing, and what they can do to help automate some of the remediation pieces that we're doing here, or to be able to make recommendations, or a lot of the sort of behaviors we've seen in other domains, how can that be applied to, software development and software security?
Yeah, last question as we wind up is just about your roadmap and just what you're working on at ActiveState. Do you see solutions for these kind of LLMs and AI related security issues on your roadmap, or are you guys working on even more pressing issues? Anything that you'd like to mention to kind of tease us on, what's coming?
Well, I think that what one of the biggest things that you'll see coming from us is what we sort of saw in the demo here, which is the ability to kind of ingest and parse all of the all that data from SBOMs and from a variety of SBOM sources, to be able to get that holistic view. And then also some of that recommendation piece that you're seeing there in terms of like, is this going to break? What's the ideal remediation here, right? We talk about it as intelligent remediation on our side. And so what are the tools that we can give people? What are those kind of, what's that, intelligence we can give people to be able to make those good decisions, whether it's a breaking change or whether it's the right version to upgrade to, that's going to, work with everything else that they're working on. And
Maybe that's a good point to throw in, is when we talk about ideal remediation, is the latest and greatest version isn't always the best remediation version for you. I mean, breaking changes are a point of your software development stack, and there's other constraints that you have. So it's like, how do we get you to the point that reduces the most amount of vulnerabilities in your system is kind of is what we mean by that intelligent remediation side of it is, and it goes back to that. We can't always get you to zero, but that doesn't mean we do nothing. We try to get you as many things as we possibly can. And how do we make that easier to consume? You spend less time thinking about that and getting more time, getting more reductions in vulnerabilities and risks.
Yeah, 'cause that real like intelligence comes when, instead of suggesting to you blindly, oh, well, you should go to the latest version. It's version 2. It can say, actually, you want to go to version 1.9 because it's going to remediate all of your critical vulnerabilities, but it reduces the risk to your overall software because it's not a major breaking change. So we recommend that you should go to this version for those reasons because it's still secure, but it's going to reduce that risk. So that's when we talk about intelligent remediation, that's the kind of thing that we're talking about. Um, in our roadmap there. And so those are like the near term things that everybody should be looking out for that'll be available.
And then
All
just
right.
maybe a little longer term that's going into the plan that we're talking about here is that we just see this correlation between how models are being developed and released on the internet to the way that open source code is being developed and released by on the internet, in communities and things like that. And we predict the same consumption patterns that you'll see here, maybe even at an accelerated rate, because I think people are a lot more comfortable these days. It goes back to that beginning of the conversation we had where people are just comfortable consuming open source. I feels like people are even more comfortable consuming models, and people are looking for ways to run them themselves instead of running them through big things. So we're predicting more and more models are going to come into your organization. You're going to need to stay on top of it. You're going to need to be able to manage that. You're going to see a new kind of class of dependency management based in and around models pop up. And it's going to have the same patterns of, well, now I'm going to need an AI bomb to keep track of the bill of materials that my AI is part of. I need to know what part components those are consuming, and we're taking a lot of the parallels from open source and applying that to the AI spaces as well.
Wow. Yeah, I mean, that's a great note to end on because that gives me an idea for what we could probably talk about in a part two of, if you guys come back after maybe towards the end of the year or something, we could do a part two talking about just security for AI models, and that would be a really interesting conversation as well.
Excellent. Would
Happy to do
be
it.
happy to come back.
Yeah.
All right. So yeah, before you guys go, just a quick question to get to know you a bit. Um, what would be your alternate career path if not for your job in tech? Yeah, yeah, I'd like to hear both of you.
Go ahead, Scott. You can start.
Oh yeah, mine. If I could have any job in the world, and maybe I've never actually had it, but I would love to work on wooden boats. For crazy thing, I'm a hand tool enthusiast when I'm not in front of my computer. It's probably that the counterbalance to my life is instead of having to be working with technology as most low tech as possible would be my other approach. But that's probably just too many years in tech at this point. So
I think it's a pretty
What tool
common
behind
theme.
you there?
Sorry, go ahead,
what was
Wade.
that?
I was just wanting to ask, what tool is that behind you there? It
Oh yeah.
looks like.
Well, this is the 3D printer, and then yeah, this is actually a. Speaking of which, yeah, it's an old
Ah.
fashioned wood plane for smoothing for actually making um yeah
Neat.
for woodworking on top of it. So
Yes. All right, Pete. Yeah, what would you do?
Uh, well, I think it's a common theme that people who work in tech for a long time want low tech alternative careers kind of thing. And so, yeah, like for me, I would be a writer. I mean, I do that now, write novels, that kind of thing. And so I would just, if I wasn't working in tech, I'd be doing that.
Okay, so you have a published novel somewhere on like Amazon?
I do. Yes, you can go to Amazon, search PJ Garcin, and you can find my
Neat.
novels.
Wow, that's fun. All right, guys, thank you so much for joining. It was really a pleasure chatting with you both. And we hope you'll join us again sometime later this year to talk about AI and security.
absolutely.
Sure.
Thanks to all of our listeners as well for tuning in, our listeners and viewers. We hope you enjoyed this conversation as much as we did, bringing it to you. If you like what you heard, go and follow us on our social media channels, YouTube, Spotify, and elsewhere. and go to our website, softwareplaza.com, and you'll find a lot of conversations on related topics. And we'll see you on the next episode. That's it for now. Take care.